All right, now we're recording. So, Jessica, take it away.
All right. Well, thank you all for coming on this Thursday afternoon. I'm going to be talking about designing and deploying Math That Matters, where Math That Matters is a two-course sequence that we've put together at Virginia Military Institute. And so just to get through what we're going to be talking about today, I'll give some motivation for why we're even having this discussion. Why did we make these changes? Why are we doing what we're doing? And then, because I like to make things fun and active, we'll actually do a little lesson demonstration. We'll break out into small breakout rooms. You'll get a chance to experience what it's like to be a student in Math That Matters for a little bit. And then we will, I'll show you a little bit more about the course itself. What are the skills that we hope that the students get out of it, as well as the context. Talk a little bit about some lesson learned, some acknowledgments, and then some time for discussion. And I want to intentionally leave some time for discussion at the end because I have invited both my math friends and my non-math friends. So yeah. All right, so why on earth did we do this? Well, first of all, we realized that we had a local need. This is part of VMI's reaccreditation. As part of SACS for our regional accreditation, we have to have a quality enhancement plan. And we realized that these courses touch about half of our students. And we found that these students who took these courses were not necessarily loving them. They also were not necessarily doing well in their follow-on courses. So anything that did require some sort of quantitative thinking, we weren't seeing a lot of strengths. And so the 8 different majors that are taking these courses are listed there. I won't read them all to you, but you can see it's really diverse. And then, so that was the local need, but then there also are these big national conversations that are happening. So I'll talk a little bit about 3 of those conversations that relate to the content, the framework, and how we're actually operationalizing these. All right, I didn't have any ice cream pictures, so there's a picture of me with my boss who is actually here. So we need to make sure that we get ice cream pictures at some point. But the motivation, that there's this ongoing conversation about pathways. If you aren't familiar with pathways means into the context of mathematics, it's the idea that we should be teaching students the things that they will need, targeting their particular either major or group of majors. And at a big school, that's great. You can have, you know, the math gen ed for nursing and the math gen ed for biology related majors and the math gen ed for econ business majors. But at a smaller school, it's harder for us to pull that off. We just don't have the bandwidth to have, you know, 8 different non-calculus based gen eds. And so we figured out how we could actually try to do this. The picture that's on the board up here, we had a meeting with the faculty from the 8 different departments that you saw listed. We asked them to tell us what kinds of skills they needed, and then we clustered them together so that we could look for those synergies. And so this was us kind of analyzing what we got back from the departments. And Troy and I actually just had an article appear in the MAA Focus, so if you were wondering more about that, you could look there. The second part, or the second big conversation, is about the framework, and this is problem-based learning and contextualization. There's a lot of evidence out there. I'm not going to cite all of the literature, but there is a big focus on a growing body of evidence about how putting things into context improves learning. It improves motivation, which lays the foundation for that learning to occur. We can also look to the National Research Council report on the mathematical sciences in 2025, SIAM and COMAP's GAME report, Guidelines for Assessment and Instruction in Math Modeling Education, of which I'm one of the co-authors. And then also just talking with our disciplinary partners, realizing that it would help to understand what their contexts are. And then from an operationalization perspective, how do we make this happen in the classroom? And we wanted there to be active inquiry-guided learning. It's not a traditional more method IBL, but we do want the students to take ownership of the learning. And so there is discovery involved. There are guided sets of questions for them to work through that build them to a realization that they have accomplished something and answered a much larger and important question. Again, there's a lot of evidence out there that shows that this is important for learning. And then I also was one of the early pre-readers, I don't even know what we're officially called, of the MAA's Instructional Practices Guide. And so while that wasn't officially out before we made the course, it definitely was influential in shaping the course. Okay, Brian, are we ready for active lessons yet? Are we ready to break out yet?
Yep.
Okay, so what we're gonna do is we're gonna be, in just a moment, Brian's gonna wave his magic wand or whatever he does. So we're gonna magically appear in breakout rooms. Each breakout room is gonna do their own activity led by our Talk Math with Your Friends leadership team. So thank you to all of those folks. And when we come back, be ready to share out your answers with the group.
Great. You ready for us to go?
Go. Thanks, BK.
Hey.
All right, team. How you doing?
Hey, Brian. What are we doing here?
Okay, I will share my screen with you. So this is, oops, I'm gonna pause the recording.
Question, Jessica, the students in this class, they're not going to take calculus, or they are going to take calculus?
They are not going to take calculus. No, this is in lieu of calculus.
Right.
All right. Brian, can you let me know when we have everybody back?
I think we're all back.
Excellent, excellent. Well, thank you all for being good sports. I was just telling the first group that came back to join us a little bit of background for the corn syrup one. So there were 3 breakout rooms that were doing corn syrup. If you were playing with bats, we'll get to you in a moment. But for the corn syrup groups, they were given some data about corn syrup consumption over a window of time, and then had to use that to fit a curve and make a prediction about how much corn syrup people are consuming in 2020. And then just sort of some background on where we are in the course when this happens. The students will have just gone through a bunch of practice curve fitting, a bunch of, making trend lines, making predictions, figuring out to do with missing data, dealing with cyclic data, like if you're looking at national park attendance that might change seasonally. And so we've thrown a lot at them already, but this is the first chance where we give them data and then we take our hands off the wheel and they have to come up with that prediction on their own without those guided questions. So the scaffolding is kind of off at this point. And so could somebody, I think it was, who is my sharer outer for corn syrup 1? Is that Amy?
I think so, yeah.
Okay.
Okay, we're Amy, can you share?
Amy was in corn syrup 3.
Okay, never mind.
Oh, sorry, corn syrup 1. Could somebody from corn syrup 1 share for us?
That's us.
Yeah,
Okay,
I think
great.
I think it was decided I was going to tell about our absurd prediction on here. So we looked at this and said, well, if current trends continue, this sure looks pretty exponential to us. So let's figure out what sort of exponential growth we're looking at. And we found our ratio of the different amounts of corn syrup in calories. And continuing that, we get our very silly prediction of about 75,000 calories per day on average. And now I feel like obviously this is like wrong and silly because of a whole bunch of other things, but it's worth recognizing that, current trends don't always continue. I think it'd be good for, I don't know if the students would know about exponential growth at all.
Yeah, they would have seen exponential growth. They also would have seen quadratic growth. And if you had thrown a quadratic on here, it actually fits really nicely.
Ah, see, I can't remember who it is. One of the people in our group actually said, oh, let's look at a quadratic. And I don't remember who that was.
That was me.
See, so smart.
Well,
Nane, you want to finish it?
awesome.
Yeah, we also just, in contrast to the absurd one of exponential, just did like a flat linear of saying this is 15 years worth of data. So what's the change in 15 years? And then tacking on another 35 years since 1985, which was also a terrifying existential crisis of how long ago 1985 was. But anyway, and so then we just check that in, which would give us 400, which seems more consumable, but also is not a great estimate of what we think really would happen.
Okay.
Great. All right. So, I'm sorry, CornSorb Group 2? Or Michelle, did you have something to add? No.
No, we just started thinking about the quadratic and then time ran out, so we never got to do a fit for that one. But
well, we also
that was it was my first instinct, but then we kind of didn't do it.
Lauren, did you have?
Oh, the other one that we had started tossing around was something a little bit more like a logistic, where it's going to come up and plateau somewhere.
Nice. All great ideas. Kate, how about your group?
Yeah, so we had data. Let's see if I can share what our data looked like. So here is our data, and we used Excel to construct a trend line and then found that a linear model seemed to look like it would fit the best, and we found the R squared of 0.971 for our linear model, which we were pretty happy with. So that gave us an extrapolated 2020 number of 252. So our guess here, our prediction, was 250. And I'll show you some of the comments when we were talking about the 250, whether or not this is a good prediction. So a couple of us mentioned that none of us are eating the same things we were eating like 3 months ago, much less, since the mid 1980s. I have teeth now that I didn't have in the mid 1980s, so that also could be part of the reason my diet has changed. The data being so old, somebody mentioned who says it's increasing linearly, although we did sort of talk about the R squared for a little bit, but didn't know if it would continue into the future. And then although our data looked linear for the time being, we didn't really know how long that sort of pattern would continue, because our data ended in 2000. So who knows, maybe it was the start of an exponential curve.
Great. All right, and group 3. Now we're ready for you, Amy.
And TJ's going to show, okay, so this is the data that we had. So we had more recent data, and ours looks like it's going down. So we also, we started by just sort of looking at it and talking about some of the factors, and then decided to fit a trend line. So TJ fit this trend line, and then we sort of extrapolated, and somebody got this equation and plotted it in Desmos, and we figured out, and again, we've got this R squared value looks pretty good. It's a good fit. And we sort of extrapolated out to 2020, but then also discussed that, this COVID-19 thing is definitely changing our eating habits. So is there anything else I missed that we discussed that I should say?
Our actual prediction?
Oh, our actual prediction was going to be, we said 96 point something, and then we thought maybe it would be a little higher. So we said like just between 90 and 100 was what we ended up with as a range. So.
Awesome. Great. So we have, answers that spanned from, was it 75,000 to 250 all the way down to somewhere between 90 and 100. And so let me go ahead and share my screen again. Okay. So this is the data when we put it all together. And we do see that there are these very clear breaks in how this story is told. And I think one of the reasons why I like this for my you know, for this particular population of students is these are my historians, my international relations folks, my economists. I want them to be able to look at trends and understand that the story changed and that it's okay to change the function. We don't have to fit a single function of this. In fact, the very next thing that we do after each group has looked and they try to stitch their answer together, they'll look at the whole data set and they're like, great, I know how to throw a trend line on the whole thing, and it doesn't fit well at all. And you can get a sixth order polynomial that doesn't look terrible, but they've already heard that that's not so great. We also talk about the idea of I could make a whole bunch of little linear ones that are perfect just by playing connect the dots. But that also isn't useful for prediction. And so giving them that skill of being able to look at a large set of data and say, which part is reasonable for me? Which piece do I want to use? And realizing that piecewise functions are not something that math teachers made up just to make people's lives miserable. I think a lot of them come in with that perspective. All right, so let's talk about our other two groups. They were playing Battleship, where the bat is intentionally capitalized because we're not looking for battleships, we're looking for bats, but in the style of Battleship. So there is a grid, and they were trying to guess how many bats. So could somebody share out who was in Battleship 1's group?
Sure, I'll share our work. Let's see here. So we had a lot of fun playing the game, and I'll let others interject. We didn't get to the discussion at the end, but there was a lot of discussion that happened throughout. I'll just kind of explain how the game went. So first of all, if you weren't in the room, the goal is this was secret here. Only I knew the actual values of how many bats are in each cell of the group. And so all they could do was guess one at a time, different or not guess, they could check one at a time locations on the grid. And so after 10 checks, they found 8 total bats, and then they guessed 80. And then they got to check 10 more locations, which is down here. And then the interesting thing to me is that they got like 5 zeros at the very end. This would have been a much different, I think, outcome if they had not found those zeros in the last 5 checks. But they did find a bunch of zeros, which helped them get a guess of 65 because they found 13 total. And then the actual total was 55. So I'll let others, someone else in the group want to explain. I think the strategy might be straightforward, but I'll let you all explain it. I remember Libby. I'm going to pick on you because you're the first name I remembered from our group.
So yeah, I think basically our strategy at the very beginning, we're just like picking randomly because we have no data. Though the first one that we got, I think Lauren picked it, was the 2 in the center. So we thought maybe the center could be a place where there's like a lot of bats. So you can see we kind of have some more guesses around the center in our first round and in our second round as well. But towards the end of our second round, I think we were seeing that, you know, I think we got a 2 somewhere else maybe, or maybe not, but we were kind of letting go of that thought that maybe they're clustered and that they're actually really just random.
Great. All right. And so there were 55 bats total, and you got yourselves to 65, and your second guess was better than your first guess. So could somebody from Battleship 2 give us an outbrief?
Yeah, I'll share my screen, and then Mary can share our group's reasoning.
Great.
All right, so we first started, like the other group, just kind of randomly picking boxes for our first round. And we got 6 bats uncovered the first time. So we did a similar method where we're like, okay, let's say there's, you know, it's going to be 60. And then one of us guessed a 10 and 50 pops up, and I was like, oh, okay, so that's not going to work. And then the next person picked a 1 and it was 200, and we were like, oh no, now there's probably some clusters. What the heck are we going to do with this? And then we tried to, you know, maybe try the corners. Are they clustering in the corners? Nope. And we'd used up our second set of 10 guesses, and we thought, well, you know, maybe there's a couple more clusters of these big numbers. And I think our final guess was, so let's estimate somewhere around 450-ish, with that ish being some window around that. And I don't know if anyone from the group wants to add or if that's sufficient. But the 50 and 200
I think
is
just
definitely
the main thing was like, we realized we probably should change our strategy from just like scaling to this. Maybe there's a couple other clusters, but otherwise we'd be guessing like 1295 or something if we multiply by 5. That seemed absurd. So
Awesome. So let me go back and share my
So
screen.
how many were there?
Yeah, Drew, how many were there? You didn't tell them?
No, we ran out of time, but we just got our guess in when we got summoned back. But the total for this was 400. There was one other large cluster that didn't get uncovered.
All right. So let's see. Give me a second to get my screen sort of reset up. If you're wondering why it's vertical, I think BK mentioned it in the chat, but basically it's so that me on my tiny little screen, I can have like the chat running on one side and pictures of y'all on the other, and my stuff in the middle. So if anybody else is out there in small screen land, I did this for you. But so for the battleship, if we look at, hello. So these are the two slopes. And by slope, I don't mean the mathematical definition. It just means like an area where bats might live. It turns out that there are two very different seasons. There's the solitary season where most of the year the bats are pretty much by themselves in these little crevasses. But during the mothering season, they might cluster together. Now, they're probably not going to cluster with like 50 or 100 or 200, but we wanted to make a very extreme case. To really, we do this lesson before we get into anything with sampling. And it's really just to give students the idea of what do we even mean by sampling? And to understand that we should know something about the underlying distribution when we are sampling, that's important to understand. So again, thank you all for being good sports. Okay, so I'm going to talk a little bit more about what we do in this course overall, the math skills, the transferable skills, and the context. So the math skills, I'm not going to read all of them here, but we do a lot in Excel. Excel is intentionally chosen because it is so ubiquitous. We want them to have fluency with Excel. Descriptive statistics, inferential statistics, data analysis, that's that trend lines and understanding about missing and messy data. Math modeling, we go through the entire math modeling process on several different problems. And then there's a handful of other things that we kind of hit as well.
How much Excel do you assume they know coming in?
None. So I think that some of our instructors, when we first started, assumed that, well, they would at least understand the basics. And a lot of students really, they might know how to open it, maybe. So we actually have there's a walkthrough guide on how they can get Excel, because we have a license through the university. So it walks them through how to get it. And our very first assignment is writing a proposal for going on an international cultural trip. And so they build their budget in Excel. And so it really is a nice opportunity for them to start thinking about it as just a way to store their data. But then we can build into that and talk about doing currency conversions in it, and then adding things and writing formulas. So it's a very, like, it starts out at the lowest level possible, but creates this like safe space for them to play with it and explore, and then build up their fluency. By the end, they tend to be pretty good with it. Any other questions on the math skills?
There's another one for the end. Keep
Okay.
going.
All right. So the transferable skills, I don't think we want our students to walk out and just know math. I think it's important that they have some other skills. So we focus a lot on communication, written, visual, and oral. I'll talk a little bit about they do a poster that they put together, and I'll talk about that in a bit. Working in groups, and I mean, it's the idea of teamwork, but also leadership and followership, understanding how to work together as a group, I think is an important skill we want them to walk out with. We want them to know the whole Office suite, so they're not just using Excel, they're using Word, they're using PowerPoint, they're learning how to take the graphs that they make in Excel and copy them and put them into Word or PowerPoint. And then we do have some other skills that we want to hit as well. The general problem solving skills, the metacognition, the realizing what have I learned. So we actually take some days and step back from the learning to reflect on the learning that has happened, as well as that idea of self-directed learning. There's a lot of spots in our worksheets as they're working through these guided questions where it says, make a such and such in Excel, and if you don't know how to do that, Google it or use the help file, or what does it say when you go to the help file for this, because we realize that we don't want them to walk out the door and they know this one snapshot of what technology was like in 2019 or 2020 or whatever year they happen to be taking the course. We want them to realize that they can continue to grow on their own. In terms of context, these are some of the problems that the students work on. From our non-VMI faculty, like I said, that funding of a cultural trip, that came from our modern languages department. The BATS came from our biology department. We have, in international studies, we do measuring democracy. So we've got a huge data set, and we we build some contingency tables and do tests for independence with those. I talked a little bit before about, with some of the folks that came back early, the trend lines for looking at the population during the French and Indian Wars. They design an art gallery that was an idea that came out of our English and humanities department. We have height and fitness test data from our commandant, and the commandant's staff also suggested that the cadets build a study to look at how they spend their time and how that might influence how good of a cadet they are. VMI infamously had a leaking pool for a long time. It was leaking 9,000 gallons of water a day, and we don't know where that went. Yeah, exactly. Yeah. So, but the question of, well, should we fix the pool? Should we keep refilling the pool, and using that as a foundation to think about the modeling process. The Army ROTC department suggested that we do a module on saving for retirement. So they build up a spreadsheet that allows them to see how a savings plan for retirement works. And that is built off of the FERS plan, which is what the Army is currently using. And then the econ business folks gave us some ideas for a model using the Cobb-Douglas model to think about different ways of modeling things. I won't talk through all of the VMI math faculty ones, because honestly, I'm less excited about those. Although we threw together one on spreading viruses real quick as a result of COVID-19 that ran in parallel with looking at cyber defense. Both of those are agent-based models where they're just exploring, how do I use a model? Once I've given a model in the modeling process, once that model pops out of a modeling process, how do I use it to understand what's really going on? The last thing that I think is super exciting about this class is the poster. They all pick, cadets work in pairs. They pick a project. It just has to be something that is of interest to them, and it has to involve some math. So it is math that matters. So here is a picture of our cadets at their Big Math That Matters poster. Clearly this is not taken in 2020. Sadly, we had to do a a virtual poster session yeah, we just were not able to do this spring, which is sad. And I don't know if we'll ever get a chance to, I don't know what normal looks like. Anyway, but you can see that they are engaged, they're excited, they're talking about this, you know, the projects that they worked on throughout the semester. And some are better than others, but it's a chance for them to take ownership and to feel pride in their work. So some lessons learned. I used the word undisciplinary on here, and it's because I don't really like interdisciplinary. I don't really like transdisciplinary. I'm a big believer in shattering our disciplinary silos, right? Like I want us to be able to work in a way where we acknowledge that there's like shared value. I don't want to just teach my students math. I want to prepare them to go out in the world and do great things, regardless of what major they're in. And so building those bridges with faculty that are in other departments, that was so important for this project. We wouldn't have really been able to do anything without them. And it was super important for us to train and support our faculty. And I could give a whole nother like hour talk just about how we did that. But I'll just leave that as a point for you all to realize if you are going to undertake something like this, it's extremely important to support and train the faculty who are teaching courses like this. Change is hard and it's ongoing. I mean, I think, so my boss is with us today, and I think there's been times that he's wanted to strangle me, and rightfully so.
Not daily.
Thank you. But change is hard, and so acknowledging if you're going to make a change like this, that you do need to be committed to going through that transition process. And for the most part, the students are thriving. We have students that are putting down on their resumes that they know Excel and they're getting, you know, great job opportunities. We have students that are doing summer projects and being able to contribute in really nice ways to wherever they are. And then the other thing that I'll mention is that because of COVID-19, this course was relatively easy for us to move online, given the nature of all the activities that we had. We were able to, you already had the guidance in place through those guided inquiry questions. And so it was a lot easier for us to hand that over to the students in that online setting. Before we get to the discussion, just acknowledgments. Pretty much everybody in my math department, that's my it's my curriculum committee there, or people who have rotated in and out of it. Luke Castle, who is my postdoc, who is sadly leaving us, but that's only because he has an awesome job somewhere else. So he's headed to North Carolina next year. Our disciplinary faculty have been great contributors, as well as helping us understand what is the downstream effect. So we have 4 faculty members who are trying to assess within their own courses what changes they're seeing as a result of us implementing these new courses. And then the Army Math Mafia and a bunch of other people who supported, you know, listened to a lot of these crazy ideas. West Point was one of the first schools to really have a math modeling course as a core curriculum required course. And so I relied definitely very heavily on that background. So with that in mind, some thoughts in terms of discussion for my non-math friends that showed up. Given what I've talked about, what are things that we can do better? Do you have ideas for lessons that we can hit? Are you willing to partner with us? And then for the math friends, I would like you to think about ways that you might take this forward in your own institution, even if it's in just a small way. Are there people in your, you know, which departments are doing things like studying trends or making predictions, running hypothesis tests, doing sampling, that sort of thing. So I will leave that there.
Great. Would you like to join me in unmuting and thank Jessica?
Hey.
So the question from the chat that we didn't get to was, people wanted your slides because they want to take this to other mathematicians, which is sort of your discussion. The video will be up, but are you sharing either your slides or your curriculum materials, Jessica?
Absolutely, I can definitely share these slides, and if people want other materials, I can make that happen too. So.
Great. Other questions?
Jessica, I had a question. I was wondering how many math faculty you have in your department and how many of them are teaching this course on a regular basis?
So we have 10 tenure-track faculty. Actually, Troy, you probably know the numbers better than I do.
Yeah, around 10 tenure track, 2 sort of postdoc, 4 or 5 adjuncts, and we probably had, 14 sections of like 101 in the fall and a couple sections of 102 and then the reverse in the spring. So it's intensive. It's like at least a quarter to 30% of our teaching load.
Yeah, and most faculty have been involved in teaching at some point. There's a handful that haven't for a variety of reasons, just involvement in other courses, but pretty much everybody has touched this in some way or another in our department.
Yeah, while people are thinking of questions, I mean, I'm new here, but I do need to say that Jessica has been amazing through all of this. She is truly the architect of this. She's driven a lot of this. She's written a ton of it, edited everything from the beginning. I mean, we were kind of at a loss in our QEP, and she stepped in and changed it all around. And, there have been many, 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 many late nights, and it hasn't always been easy. But the students are, I think they're for the first time maybe seeing what a true math class is supposed to be. We even had colleagues that still say, it's okay to just have them do 10 problems that are just like the one I did on the board and then forget it 2 days later. And these kids are coming back with stories of, and she said it, one kid said, he probably got a job interview just because of the Excel skills. We had another kid looking in Virginia Beach at different power lights and using Excel spreadsheets to manage this. So for these students to see, how do you take problems from the real world really? How do you communicate? There's a ton of writing that goes into this, and even colleagues saying, wait, this is a math class? I'm grading little essays and all this writing, and they totally missed the point that that's exactly what our students are going to be doing, and that's exactly what we should be teaching. So it has been hard. There's been this big transformation, but Jessica's been the spearhead all along. So thank you to her.
Thank you. Yeah, Amy.
I know you said you could spend an hour on this, but I wonder if you could spend at least a minute on like how you did support the instructors, because if everybody's learning to teach this and it's so different from what we're used to, what did you do to help them make that transition? And probably there was some instructor buy-in involved, I'm going to guess.
Yes. So we had it's a military school. We had a boot camp. That's what you do, right? But we had a week-long workshop before the kickoff semester. So it was in the summer, and we did like the 30,000-foot view of what is the course, as well as had some experienced leaders, like people who had done a lot of inquiry-based learning type teaching before, run a couple of the lessons with the new and like the incoming instructors as sort of like mock students, but basically experiencing it from the student perspective. And then as we worked our way through the week, they had a chance to lead lessons. So that was our initial ramp up kickoff. We have done several mini boot camps since then for people that are rotating onto the course, as well as new faculty that have been hired. Those are much shorter sessions. And then we also are doing weekly meetings. And I know that weekly meetings are something that some departments love and some departments hate. And we were not a department that created weekly meetings. But I think it's been really helpful. And I think we've learned a lot in running those meetings, because when we first started, it became a space to just vent about what had happened past tense, and we weren't really leveraging that time to look forward to what was coming next in a very healthy, productive way. And so lesson learned, we have adjusted course, and I think that I think our meetings are a whole lot healthier now, where we do get a chance to, we do still reflect on, well, what happened, what could we do better, but in more of a constructive criticism type way. And then also using that time to think forward. And when there is something where it would be helpful to do a demonstration with us as a group, because it is a particularly unusual activity, like the battleship activity, right? Like that's something that you want to actually do yourself before your students do it. So we create that space inside the weekly meetings.
Thank you.
Yeah, Boomer?
So,
hey, Jessica, I think just a couple of comments. I think as a non-math person, this is fantastic because it helps understand that you can, and your idea of, you know, breaking these silos is great, because, you know, I'm a huge fan of E.O. Wilson and his resilience idea of, you know, the interconnectivity of different you know, fields of study and how they overlap and you can learn from each other, and I think this will help a lot, and your program is really good. Two, as a former Army officer, I think this, you know, 50 or so percent of VMI's cadets get commissioned.
Yep.
And so what they need to know is not just how to do this, but the so what of what they're doing, because they're going to go and they're going to go have a boss that is going to be a decision maker somewhere in the Army, the Navy, or wherever they go. And so they need to be able to take this information and go to their boss and say, here's this Excel spreadsheet. And the boss is going to go, well, what does that mean? The so what? And they need to learn how to extrapolate it and explain it. And I think a class like this, with some buy-in from some other faculty and some other you know, classes or whatever, can help them get to that. And so I think it's a fantastic process, and I'm very excited about it. I think it's great.
Thank you. Yeah, I agree. I've spent my fair share of time at the Pentagon myself, so I get it. And that's one of the reasons why 3 out of those 6 other outcomes were related to communication. We have them creating an action memo at some point. We have them writing executive summaries. We have them writing proposals. And so getting them to communicate that so what is important. Thank you for emphasizing that point. There's a bunch of people with hands up. Charles Weaver has a hand raised.
Yeah, I had a couple of questions. Is this mainly a terminal course for people? And if not, where do they go from there?
So this is a terminal course. It's a 2-course sequence that gives them their math general education credit. So every cadet at VMI is required to take 2 math courses at a 2-course sequence, and it's either calculus. And so that's what our engineers and chemists and applied math majors, et cetera, they're taking the calculus track to check that box. And then they take a bunch more math too, obviously. But then this is the 2-course terminal general education math sequence.
Too bad everybody doesn't take a class like this.
I'm sorry. What?
It's too bad that not everybody takes a class like this, because calculus classes don't make you scramble like this.
Yeah, I mean, one of the reasons why I wanted to have this talk is I would love to see this get exported. I'd love to see other people, you know, do something similar at their own institution. And I'm certainly happy to help with that. So, Meredith?
Have you gotten pushback from the students at all when you give them activities like this? Like, we've done similar-ish activities in our business calculus class, and you always end up with some of the students just like not engaging at all. Is there a way you've been able to help get them to engage more?
I think being in a military school kind of helps with that. They already have to do weird stuff all the time, and just because somebody with rank told them to. So that's part of it, but there is part of that buy-in. And so our very first day, I don't know if you're familiar with Dana Ernst's, his work in setting the stage. We use his setting the stage activity, which really creates that buy-in for why are we learning this way? How do we learn new things? What is it that we want to be able to remember in 5 years and 20 years? And so I would definitely recommend looking up Dana's stuff. If somebody could like throw that in the chat for me, just so that Meredith has it. Atin, you had a question?
Yeah, well, actually a comment. One of the cool things about this sequence, so I'm in the economics and business department at BMI, and what this sequence has done is sort of created a baseline that then continues on into our sequence. And so we have a tools class now that is sort of developed based on Math 101, 102. That's sort of an extension. And then that becomes the start of an internal sequence for us that goes into statistics, econometrics, other calculus-based courses. And so I think one of the issues was, is it terminal? I mean, it doesn't have to be. It's also sort of a foundation for many of the other courses that we teach. And my sort of brief, I mean, this is kind of a new thing, and I'm still seeing kind of the end results sort of filtering into my classes, I guess. But I can kind of tell you that, one, they know what Excel is, I guess, and that's a plus. But they also kind of seem to have a better grasp of, when I tell them to use something like Mathematica or something, they're not just completely off the wall, and so that's been helpful.
So Tin, you asked a question about buy-in across the Institute as a whole, and Atin just, I think, addressed some of that, but I also saw Turk had his hand up, and he's in our history department. So Turk, could you share?
Yes, I'm a colonial American historian, and I do research that most people would call in social history, but that's like social history used to be done 40 years ago with some math in it. And just this past fall got approved at BMI a course on quantitative history that will, I hope, will pull cadets from all majors, but most of whom have got this background coming out of this Math That Matters sequence, to work problems based on a data set that I've built over a long period of time about debt litigation on the Virginia frontier, so from the 1740s to the 1770s. And what I've found is it actually really seems to appeal very, very nicely to cadets, not just history majors. And that my honors student, this who just graduated, or will tomorrow, did an honors thesis that was a quantitative analysis of one particular type of debt litigation. So, and he did it. He came out of this Math That Matters sequence and through the quant history course. So it does work. It is also an enormous amount of work. So
thank you. Yeah, thank you all for answering. The reason I asked was just because it is very different, right? A course like this, and especially a 2-credit course. So I just worried, just wondered about, getting people to try something different or try something new for their students. But thank you all for your answers.
Well, we need to wrap up, but our next week's speaker is here. So Mitch, do you have a 30-second summary you'd like to share with us?
Sure. So next week, I'm going to talk about interval orders, which are a specific class of partially ordered sets. So we'll be doing combinatorics. We will count things, and we will have characterization results. And so I hope it will be interesting. We'll see a little algorithm and get to talk about some sequences, old and familiar and brand new. So I see the chat is blowing up with somebody who likes counting things. We will be counting. There will be generating functions.
Excellent. Okay, can we thank Jessica one more time for a wonderful talk?
Thank you guys. No, this was great. It was a really good discussion. So